Today, we're going to derive the surface area of a sphere using a cylinder. Here is a cylinder. This is the diameter of the cylinder and its height is the same as its diameter. This is a sphere. The diameter of this sphere is the same as that of the cylinder. When this sphere is cut into two halves, we get two hemispheres like this. This is the radius of the hemisphere. In the hemisphere, both the height and the radius are equal. Let's begin the activity by wrapping this hemisphere with a thread. For that, we have fixed a pin at the top of the hemisphere. The hemisphere is now completely covered. Mark the end point of the thread with a sketch pen. Then, cut the thread at this point. Let's tape the end of the thread to the hemisphere so that it does not open out. Let's keep this aside. Now let's see how much of the thread is required to wrap the cylinder. Let's tape one end of the thread to the cylinder. Wind the thread along the surface of the cylinder till it's completely covered. Once the cylinder is completely wound, this is how it looks. Now we need to compare the lengths of the thread used for the hemisphere and the cylinder. Let's slowly unwind the thread from the hemisphere and then from the cylinder. Let's lay them straight side by side on this table. We can see that they are both not of the same length. When measured, the thread from the hemisphere measures 18 meters, whereas the thread from the cylinder measures 36 meters. From this, we can conclude that the surface area of a hemisphere is equal to half the curved surface area of a cylinder, or the surface area of a sphere is equal to the curved surface area of a cylinder. The curved surface area of a cylinder is 2 pi r(h). So, the surface area of a sphere is also 2 pi r(h). The surface area of a sphere is also equal to 2 pi into r into 2r, as the sphere has a height of 2r. Now, on multiplying, we find that the surface area of a sphere is equal to 4 pi r squared. Thus, we derived the surface area of a sphere using a cylinder.